In this video, I'm going to talk about how to solve systems of linear equations. Systems of linear equations. That means more than one linear equation. Linear equations, remember, are equations that give us lines. So a system is where we have more than one linear equation, and when we solve it, we get a solution. And specifically, a solution to a system of linear equations is a point on our graph. And this point is actually going to be the intersection of two or more linear equations. So let's do an example and we can talk about all this a little bit more. Let's try negative 2x plus y equals 5 and x plus y equals 2. Alright, so these two linear equations are in a standard form. So we could solve it in a standard form, but that's a little difficult. I would rather put it in slope-intercept form or y equals mx plus b form. So basically we're going to solve each of these equations for y, and then we'll be able to graph it a little bit easier here. So if I take this first equation and I solve for y, I would add 2x to both sides. That would get rid of the negative 2x over here and move it over to the other side. So this equation is going to be y equals positive 2x plus 5. And we can graph that. Remember, this is our y-intercept. It's our starting point. We start at positive 5 on the y-axis. Alright. And then we use the coefficient of x, so that number in front of the x right there, that's our slope. It tells us how much to go up or down or left or right. The slope is positive 2. We're going to go up 2 and over 1. Up 2 over 1. And if we want to work backwards, we could always go down 2 and left 1. So from here, go down 2, left 1. And we still keep our slope the same. Still positive 2. Let's go ahead and connect these points. And we may need to continue it over here depending on where this next line is being graphed. So now let's take this second equation right here. And let's solve that for y. So we need to get rid of this x, subtract x from both sides, and we get y equals negative x over here plus 2. So again, we start at positive 2 on the y-axis. And now this slope, we have a little bit of a mystery here. This is an invisible 1 there. So it's actually negative 1. So that's telling us to go down 1 over 1. Down 1 over 1. And if we do it opposite, we would go left and up 1. Well, if we do that from here, we end up at this point, which is sharing the other line. So we have an intersection of two lines. It's kind of an ugly line there, don't worry about that. What we're really focused on, though, is this intersection point. This intersection point right here is the solution of our system. That's the answer we want to give, and we're going to give it in this form, coordinate pair form. So the solution is negative 1 on the x and positive 3 on the y. So this is our solution right here. We want the intersection of those two lines. Alright, so one solution, there was one intersection point, so that's one solution. We do have two other ways that we can talk about solutions of systems. So two other different answers that we can get. This is our one intersection point and our one solution example. Let's talk about another example of a system. We could also have many solutions, and even more specifically, we could even say we have an infinite amount of solutions. And let's see what that looks like. How is it possible that we can have an infinite amount of intersection points or an infinite amount of solutions to a system? let's graph 3x minus 2y equals 6. Let's just graph this one first. Let's solve this one in standard form and get a little example of different forms of linear equations. If I set y equal to 0, so if our coordinate pair where y equals 0, what is x? Well, if y is 0, then this whole thing goes away, and then it's 3x equals 6, so x must be 2. So at 2, 0, it's called an x-intercept. This is called an x-intercept. We know our graph is going to cross the x-axis at that point. We could also find the y-intercept pretty easily by doing just the opposite. Let's set x equal to 0 and then solve for y. So we get negative 2y equals 6. And we would know that if that were the case, then y would have to be negative 3. So at 0, negative 3, that's our y-intercept. Now that we have 2 points, we can always connect them with a line. And if we want to continue that line, which I'm sure we'll need to do, we could come up with the slope. It goes up 3 over 2. So just continue it. 1, 2, 3 over 2. 1, 2, 3 over 2. And that's kind of a different way that we can graph a line. It's always a little easier instead of having to solve this entire equation for y, but it only works really well if these two coefficients are actually easily divisible into this other variable here. Let's get our other equation going here. 6x minus 4y equals 12. So again, both of these numbers easily go into this number, so we could solve it in standard form pretty easily. But we could also just compare something here. Let's compare these two equations. Hopefully you can see that this equation is really just the first equation doubled. Everything in this equation got multiplied by 2. 3 times 2 is 6. Negative 2 times 2. What did I say? 3 times 2 is 6. Sorry. Negative 2 times 2 is negative 4. And then 6 doubled over times 2 is 12. So hopefully you can see that this is actually the same equation. And it should actually be the same exact line. Let's see what happens if we solve it. We can make it even more clear if you want to do it in slope-intercept form. Let's solve for y. See what happens here. So subtract 6x from both sides. Then we get negative 4y equals negative 6x plus 12. And then divide by negative 4. Divide by negative 4. And divide by negative 4. So we finally get y equals negative 6 over negative 4. Well, a negative divided by a negative is a positive. And 6 over 4 reduces down to 3/2. X stays the same. And then 12 divided by negative 4 is negative 3. So if we start at negative 3 and go up 3 over 2, hopefully that makes it absolutely clear that this is really the same line. And if we have two equations talking about the same line, well, those two equations are going to have an infinite amount of intersection points. They're always going to be intersected because they are the same line. So anytime you see two equations, they could be written differently, they could look like different equations, but if they ever end up being the exact same equation, then we say the solution of that system has many or an infinite amount of solutions. Alright, one more different type of solution we can have in a system. We can have no solution. That's where two lines never intersect. And hopefully you're thinking, well, they must be parallel lines if they never intersect, right? So if you ever graph two lines and they're parallel, the solution to their system, we just say no solution. So let's take a look at that example. 3x minus 2y equals 6. Let's graph this one first. Again, this coefficient and this coefficient easily go into this number, so we can solve it in standard form. let's set y equal to 0 and solve for x. So 6 divided by 3 is 2. 2, 0. And that's our x-intercept. Our y-intercept is coming up. So if we set x equal to 0 and solve for y, then we get negative 3. So basically the same thing we got last time. If you remember, the slope was up 3 over 2, so we can continue that right there. Should give us hopefully enough room to see or compare these lines here. Arrows on the tips of our lines. Here's our other equation, or the other line. 3x minus 2y equals 2. Well, this doesn't easily go into that number, so I wouldn't want to solve it the same way I solved that one. Let's solve for y again. So let's subtract 3x. And we get negative 2y equals negative 3x plus 2. And then divide by negative 2, so we get y equals positive 3 halves x minus 1. So we start at negative 1, and we do the same slope. 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. And if you remember, a definition of a parallel line is that two lines are parallel if their slopes are equal. Well, these two lines have the exact same slope, and so they must be parallel. And when we graph them, we can actually see that they are in fact parallel. They will never intersect because the slope is the same. They're never going to intersect. And we have a solution. Well, we don't have a solution, right? That's our solution, is that we don't have a solution. It's no solution. They will never intersect. Alright, so the three ways, there are three solutions of systems. Three solutions of systems. Let's just review real quick. The first is that we have one solution, and that's one intersection, right? One intersection. And our solution is that intersection. It's our xy coordinates of the intersection. Second solution we can have is infinite or many solutions. That's where we get basically the same line, right? And our third solution is that we don't have a solution. So no solution. And that happens when we have parallel lines. Alright, so I'm going to continue talking about systems of linear equations for another video. So we'll continue this conversation, and we'll talk about how we don't necessarily have to graph it to find the solution. We can solve it algebraically. So I'll show you how to do that in the next video.